I originally saw the posting for this PhD position on an email listserv um, for isotope geochemists, and it was a listing to work at the Appalachian Lab with doctors Dave Nelson and Keith Eshelman, two professors here at the lab. It was a project that's very different than what I've done before, but it was topics I'm interested in, specifically using isotopes to trace nitrate through watersheds, and then it involves hydrology, which I was interested in getting more involved in. And so far, it's been finishing up my first year. It's been a great experience with both my advisors. They both bring very different things to the table. Keith Eshelman, is more of a traditional hydrologist, but he's done a few decades worth of work in Western Maryland watersheds and water quality monitoring. Dave Nelson is really an expert with the isotopes, so it's kind of nice having co-advisors that bring very different backgrounds, perspectives to the project. I think it enhances the project and kind of our discussions and where we want to take things. So we are researching nitrate export in streams and rivers draining a variety of land uses. So we're looking at watersheds that are mostly forested, watersheds that have large proportion of agriculture, and watersheds that have large proportion of urban areas, and then also watersheds have a mix of all three. So we're measuring not just the amount of nitrate that is exported from these watersheds, but that we're then using isotopes of nitrate to try and assign sources to figure out where this nitrate is coming from. So is it coming from fertilizer? Is it coming from microbial sources? Or what we're really interested in is how much is coming from atmospheric sources. It's moving through the watershed without being used by plants or microbes at all. If we know how much nitrate is coming in from the atmosphere, and then we can quantify how much of that nitrate is leaving the watershed without being used, it can allow us to make inferences about some processes that are occurring within the watershed. So if you have a forested watershed that's not using any of this nitrogen that's coming in from the atmosphere, it can tell us something about, well, maybe this forested watershed has all the nitrogen it needs. So any excess nitrogen that's coming from the atmosphere just can be exported downstream and can have detrimental impacts to downstream water quality.